Today we're going to look at exponential regression. So to do this, you can take any data that would follow an exponential growth pattern or exponential decay. So some things that grow exponentially are populations like bacteria, like in a petri dish or something like that. Or investments, money being invested, typically an exponential growth. Exponential decay, which would have this more of a shape that would be a decreasing pattern like that. That could be the half-life of a radioactive element or something like that as it decays, anything like that. Or maybe a population of bugs after a pesticide has been sprayed or something. So those are some options. In news right now is the coronavirus. So we're actually going to look at the coronavirus cases. So here I am, I'm looking up the CDC's website, and they have the list. Today it is March 27th, so that's where all the data is currently. And we're going to look at, scroll down here on the page a bit. You can see the number of cases in the United States. Started out we didn't really have anything. Started growing a little bit in February, and then in March, the cases that's when they started to increase, and here we are at this pretty rapid growth of number of cases in the United States. So really, like I said, it kind of started out around March. Beginning of March would be what we only had about 30 cases in the United States, and then it started going up, so that's a pretty good timeline to start. And it makes our numbers easy also. So if you just look at the data, I'm going to type in February 29th as day 0, and then March 1st would be day 1, 2, 3, 4. March 5th would be day 5. So taking all of this data, you can scroll through the website and get the data. We're going to enter it into our graphing calculator. So to do that on a Casio, you just go main menu, then option 2 for stat. And then, like I said, day 0, we would enter in from the website 24 cases. And then on the 1st, 2nd, 3rd, it goes 30, 53, 80. I have a wrong number entered right there. 30, 53, 80, and so on. Go throughout the entire month. So far, entered this up to day 26, which is as far as this data is reported at the moment. So go ahead and get all that typed in to your calculator. And then to do exponential regression, that's calc regression. So that would be F3. And we're looking for exponential, so we first need to click more, F6 over here, to get EXP for exponential. And then AB to the X, so that is F2. And we've got our regression equation here, the exponential regression equation. So now we can copy that and paste it by clicking EXE. It'll automatically paste it. I'll show that again. F6 to copy, and then EXE to paste. And that will take that information and put it directly into your graph. Menu option 5. Now, if you just hit draw right now, you'll get a condition error. I've talked about this in class before, but You just need to select it. That's all that means. You need to F1 so that you can select. You'll see that on the equal sign, that toggles between being highlighted or not. We want it to be highlighted because we're going to graph it. And then F6 to draw. So your view window, probably a standard view window, and you won't really see much information. So what I would recommend, since we're talking the month of March, we can talk about day 0, which was actually the last day of February, the 29th day of February, since it was a leap year. And then we'll go all the way up to the end of March, so 31, and that takes us for the entire month for our x-axis. But we don't see anything because our y values, we know from looking at the data, go way up into the almost 100,000, 85,000. So we can either manually set that in the view window. We can change our y's from 0 up to 100,000, but we know it's going to go past that in our model, at least in the next few days. But we could still type it in there if we wanted to. Or your other option is that you could do a zoom, which is F2, and then auto, which is F5. And that will automatically fit the window. If you check your view window now, you can see that it goes up to 560,000. That's how far up they had the graph go now. So we do have this equation. We can use this to predict. Now, this doesn't work for predicting really far out. That's not what regression does. But it could predict maybe the next day would be approximately correct. It gets a little bit crazy, like you said, if you look all the way out, because eventually what's going to happen with a virus, early on, it will model exponential, but it will also then start to taper off, and there will be less and less illnesses. So it's not quite an exponential, it just starts that way. So, looking at our graph, we could use this. We could predict, we wanted to know how many cases there would be on the 29th, or let's see, the 30th or 31st would be Tuesday. That would be a little bit reasonable we could look at. So we can type in our x value for 31, and it says 560,000. So by the time you're actually looking, watching this video on Tuesday, we can check that. And now what this will tell us is actually if the number is less than 560,000 cases in the United States, which would be great. That means that what we are doing as a country to prevent the spread of the disease is actually helping. For example, right now we can look at some of our current, like the current day, 27th, as I'm doing this. It says 157, and that's actually already an overestimate. Well, actually, we didn't have today's data. We had yesterday's data, the 26th. But it was still already an overestimate. So, as we trace this back, if you click F1 to trace, we can look and we can see if these are accurate at the moment or not. So for example, we can look at the 20th, and it's 18,000, and from the website it says on the 20th, 18,000, so that was pretty good. 21st was 24,000, there we are, right about pretty accurate there. As we move out a little bit to the 23rd, it says 46,000. Also pretty close, like we said. So what we actually have then, looking at those dates, those are pretty accurate. Looking at the 25th, 86,000. 25th, only 68,000. So that could actually be an indicator that we've already started to slow the spread a little bit, which is what we're looking for. So that's a good thing, where this graph will start to taper off. So that's really a real-life application, how we can use regression and modeling. That's what a lot of experts are doing right now. Like I mentioned, exponential growth is only at the beginning, and then it does start to taper off. There is a different model for that, but that's not today's lesson. So, your homework for this, your activity that I want you guys to do with this, is to actually go to the weather.com, because on weather.com, I will reload this here so it's the homepage. There's a COVID-19 tab, and they actually have really good data that you can choose for whatever state or location that you would like. So I was looking up New York City because New York has a lot of cases currently. And this is for the county. If you click state, you can see the entire state. But again, you see that it does have a bit of an exponential growth pattern to it. And then for this one, if you want data, you have to hover over and get or if you're looking at it on your phone, you can click on the bar from the bar graph, and it will tell you the number. So what I would like you to do is pick a state of your choice, and you can look at the growth of it. Now, you might not want to just do the day in March. You could probably make that work out, where you just do first, second, third, fourth, enter those for your X values. You could also shift them and say X equals 0 could be March 11th or something, and shift all of your data that way. So if you choose, or maybe X equals 0 is March 10th, then that would be pretty easy, because then you're just entering in the ones digit until we get up to the 20th. That would obviously be 10, and then 12, so on. So go to weather.com. You're going to make a list of, like a table, an XY table for the day, as well as the number of cases. And then you'll type it in, go to exponential regression, just like we did in this video. Get the equation, also write down the equation, just like what it is here. You can round, obviously don't write this many decimal places, so it'd be 30.461 times 1.373 to the x. So just write down your equation. So that's going to be our assignment for this, is to make a table of the data on a piece of paper. Use your calculator to get the regression model, write the equation, and why don't we, and then the last step would be to predict for the end. Well, you'll be doing this on the 31st. So just get the equation for it, and we'll go from there. So that's it. Post your questions and let me know what you need going through for this. Again, you can choose whatever state you would like. Just make sure you include the state also, so we can check your data.